contour integration, this integral is also of the same kind. So the integral is from minus infinity to infinity, e the power ax over 1 plus e the power x dx equal to pi over sine a pi. This we need to show, and it is given that a is strictly greater than 0 and strictly less than 1, which means a is again not an integer. So to prove this integral, we will integrate fz equal to. So what is fz? In the numerator, it is given to us e the power ax. So taking the numerator for fz, e the power az over 1 plus e the power z. Just replace x with z. So we will integrate this function along the contour, which is followed by the lines x equal to this positive r, and then x equal to negative r, and this y equal to 2 pi. Already mentioned this distance as 2 pi. Okay, so we will integrate first along the real axis, and then along this line, and then along this line, and then along this line. First is just writing the poles of the fz. So taking the denominator to be 0, we get e the power z equal to negative 1, and this we know that this is e the power pi iota, so z coming out to be pi iota. So this z lie inside the contour because this distance is already 2 pi, so this is half of this, so pi iota lies inside the contour. As the axis is imaginary, so we should write iota. Okay, second step is to finding the residue of the fz at that point, pi iota. So the formula for calculating the residue, just write the numerator as it is of fz, which is e the power az, and then derivating the denominator with respect to z, which is 1 plus e the power z at z equal to pi iota. So this is equal to e the power a, writing the value of z as pi iota, and when we derivate this we get e the power z. So again putting the value, this is e the power pi iota, and e the power pi iota is negative 1. This we all know that this is negative 1. I have already explained this in the previous video. So this is e the power a pi iota with negative sign. Third step is using the Cauchy's residue theorem. So the complete integral over c fz dz equal to 2 pi iota times the calculated residue. So this is negative e the power a pi iota. So this is equal to negative 2 pi iota e the power a pi iota. Now in the next step we have to split this contour into many integrations, right? Okay, so I have drawn this contour again. So first we will integrate the function along the real axis. So here if you check on this real axis y is 0. So here x is varying and y is 0. So taking z to be as x only. So this is e the power a x and 1 plus e the power x, and the limits are from minus r to plus r. Then integrating along this line where y is varying, so z becomes, what is x? X is constant, which is positive r, and y is varying, right? So taking z as r plus iota y, e the power a r plus iota y, 1 plus e the power r plus iota y, and writing iota dy. Please do not forget to write iota, alright? Thank you. Okay, the limits of y, here what is y? It is 0, and here y is 2 pi. Then third, we will integrate along this line. So here x is varying and y is constant, which is 2 pi. So now z becomes x is varying and y is 2 pi. So writing e the power a x plus 2 pi iota over 1 plus e the power x plus 2 pi iota. And the limits from positive r to negative r. Now integrating along this line, here x is constant, which is negative r, and y is varying. So putting z as e the power a minus r plus iota y over 1 plus e the power minus r plus iota y, and writing iota dy, and the limits. Here the value of y maximum is 2 pi. Sorry, because I'm starting from here to and reaching at this point. So lower limit becomes 2 pi and upper limit is 0 for y. Okay. Let me mark this as 1. So in the integrals where you find r, capital R, just take those integrals, right? Not about the limits, but in the function where you find capital R, just take those integrals and taking their mods, and let's check what happens. These integrals will tend to 0 as r tends to infinity. Let's check. Please note here I will use this inequality, which is mod of a plus b is greater than equal to mod a minus mod b. And if you take the reciprocal, the sign will change to less than equal to. So I will be using this inequality here. Okay, so the mod of first integral, this is less than equal to mod of 0 to 2 pi, this integral weight. This is 0 to 2 pi mod of e the power a r plus iota y over mod of, can I write this in the first place? Doesn't matter, plus 1, right? And then mod of iota dy. Is this clear? Okay, we know that mod iota is 1. Yes, and we also know that mod of e the power iota y is also equal to 1, right? I have already explained this. Please check the previous video. So this is this is 1. Okay, let's solve this. This is further less than equal to, I'm using this inequality in the denominator. So this is 0 to 2 pi, because taking the reciprocal, the sign will be less than equal to then. And mod of this is e the power ar, because it can be written as e the power a iota y. And if you take the mod, this already gone to 1. Over, this is again e the power r after taking the mod. This is mod of this. Okay, I write the step. Minus mod of 1. Is it okay? All right. So mod of 1 is, okay, this is 1. And this can be written as e the power r dot e the power iota y. And this mod is 1. So lefting up with e the power r only. So that is why, let me write here now as e the power r plus, oh sorry, minus 1. Thank you. Now taking this e the power r common and taking this to the numerator, so this will become e the power a, okay, this is just right. Okay, I will integrate later. So this is e the power a minus 1 r over e the this is 1 minus e the power minus r, because we have taken this common, and this is whole is constant, and integrating 1 with respect to y, which is 2 pi. So this is 2 pi e the power a minus 1 r over 1 minus e the power negative r, which is tending to 0 as r tends to infinity. Please check the power. What is given to us about a? That a is strictly greater than 0 and strictly less than 1. Right? So if I subtract 1, I get negative 1. A minus 1 less than 0. So this is negative. So if a minus 1 is negative and if r is tending to infinity, this will tend to 0. Right? Numerator will be tending to 0. Is this fine? Which means taking limit r tends to infinity on this mod will give me the answer 0. So taking this limit r tends to infinity on this mod, so this is less than equal to 0, which means if mod is less than equal to 0, then same mod is then equal to 0. This is the property. This is the result. Alright. So furthermore, this is equal to 0. Right? Okay. So let's solving this second integral, taking the mod. Right? Please note that e the power x plus iota y, this mod is e the power x only, because e the power iota y mod is 1. Okay. So this is less than equal to 2 pi 0, 2 pi to 0. So mod of e the power a minus r plus iota y over mod of 1 plus e the power negative r plus iota y mod of iota dy. So this is less than equal to, just wait. Okay. So this is less than equal to, can I write this as e the power, just let me solve this first. This is e the power negative ar, fine. And then in the denominator, I'm applying the that inequality, that is e the power negative r 1 minus. I'm using this inequality. So this is 1 minus e the power negative r, and mod of iota is 1. So this is dy, this is constant, and integrating with respect to y, that is integrating 1 with respect to y, that will give me minus 2 pi. So this is equal to wait, you can't write this as minus 2 pi because already I'm having mod this, and mod can never be less than equal to the negative, right? It can never be less than equal to the negative quantity. So it is fine if I change the limit in the beginning, because in the mod if I change the limit, so I'm having the negative sign, that will, because it is mod, then again that will become positive only. So it is easier for me to write this integration as 0 to 2 pi with positive sign only, because I'm having the mod. I can change the limits inside the mod. I'm having the negative sign, and because I'm having mod, that negative sign will disappear. So I reached here now. So this is then 0 to 2 pi e the power negative ar over 1 minus e the power negative r, right? And dy. And because all this is constant, so integrating 1 with respect to y will give me 2 pi. So this is equal to 2 pi e the power negative ar over 1 minus e the power negative r. Now this is fine. It is very important to change the limits first, right? Otherwise you will get the negative quantity, which cannot be possible. Okay. Now as r tends to 0, this will tend, as r tends to infinity, this will tending to 0. Let's check the power. I'm having negative a. I know that it is given to me that a is strictly greater than 0 and less than 1. For negative a, sign will be changed. So this negative a is less than 0, which means this is negative quantity, right? So that means this is negative. So when r is tending to infinity, the numerator will tend to 0. If r is tending to infinity, this numerator will tend to 0. Okay. So these two integrals vanishes. Second one and fourth one. These two integrals vanishes. So we have left up with first and the third integral only, right? And we have to apply r tends to infinity in this equation. Wait. This is equal to, when splitting this contour, this is equal to negative 2 pi iota e the power a pi iota. I forgot to write negative 2 pi iota e the power a pi iota. I'm very sorry, I forgot to write this. Sorry. Okay, so we just apply this r tends to infinity on this first, which we have marked as 1, this first equation. So when this tends to 0 as r tends to infinity, which means if I apply limit r tends to infinity on this mod, which is less than equal to 0, which means this mod is equal to 0. This is a result, which means limit r tends to infinity. If mod is equal to 0, mod of something is equal to 0, then that is equal to 0. So this is 2 pi to 0 e the power. No need to change the limits, it's okay. So the denominator, this is very important example. So this is equal to 0. Now letting r tends to infinity in 1, we get minus r to r will change to minus infinity to infinity e the power ax over 1 plus e the power x dx plus, then the plus infinity to negative infinity e the power a x plus 2 pi iota over 1 plus e the power x plus 2 pi iota dx. This is equal to minus 2 pi iota e the power a pi iota. Fine. Okay. Now I know that writing this integral as it is, I need to change this sign, this limit, and then the sign will be changed for the integral, because I'm having minus infinity to infinity. So I need minus infinity as the lower limit. So sign will change to negative. And this is e the power ax, and e the power a 2 pi iota, right? E the power a 2 pi iota over 1 plus e the power x, and e the power 2 pi iota is 1. And this is dx. This is equal to minus 2 pi iota e the power a pi iota. Then please notice this. This is same and this is also same, right? So this is your constant e the power 2a pi iota, and here from 1, taking this common, these constants, 1 minus e the power 2a pi iota. This is common, and this is from minus infinity to infinity e the power ax over 1 plus e the power x dx. Is it okay? Yes. Now taking this to the other side, minus infinity to infinity e the power ax over 1 plus e the power x dx is equal to, taking this to the other side, this is minus 2 pi iota e the power a pi iota over, if I take minus common, that will be cancelled out with this minus sign which is present in the numerator. So I'm writing e the power 2a pi iota minus 1, right? Okay, so taking, because I'm having e the power a pi iota in the numerator, so taking e the power a pi iota common from the denominator and cancelling them. So this is 2 pi iota over e the power a pi iota minus e the power negative a pi iota. And this is a very beautiful formula for sine, which is 2 iota sine of a pi. Right, so this 2 iota will cancelled out and we're left up with pi over sine of a pi, and the result is proved, right? This we have to prove only, right? So we have reached, so this integral minus infinity to infinity e the power ax over 1 plus e the power x dx is finally is proved to be equal to pi over sine a pi, hence the result. Okay, thank you so much.